Good afternoon. My name is Gustavo Alberto Albarrán, and I'm a master's student in Engineering Sciences at the National Technological Institute of Mexico, Toluca campus. The focus on my research is on developing anti-corrosive coating for bipolar plates in proton exchange membrane fuel cell. Uh, the introduction, the polypyrrole, sodium dodecyl, sulphate, carbon nanotubes composite is signed out for its electrical and thermal properties, high corrosion resistance, uniform particle distribution, strong adhesion, and homogeneous dispersion. This feature enhances both durability and corrosion resistance, while also being cost effective, make it an ideal candidate for anticorrosive coatings in PEN fuel cell plates. And now the problem, the materials used as bipolar plates are a key component in the PEM fuel cell. These are usually made of steel. However, this material presents corrosion problems which affect the performance of the fuel cell. The synthesis of this composite followed a specific methodology. The distilled pyrrole was used with sodium sulfate and as the oxidant, sodium dodecyl sulfate as the dopant, carbon nanotubes as the filler, and distilled water as the solvent. These reagents were mixed and subjected to sonication, followed by introduction into an electrochemical reactor operating at 4 volts, 40 milliamperes for 30 minutes. This process yielded three coatings: polypyrrole, polypyrrole sodium dodecyl sulfate, and polypyrrole dodecyl sulfate carbon nanotubes. The characterization of these coatings was performed using scanning electron microscopy, Fourier transform infrared spectroscopy, thermogravimetric analysis, electrical conductivity measurements, and anticorrosive performance evaluation via open circuit potential. The same micrographs revealed the typical cauliflower morphology of polypyrrole along with particle agglomerations. Additionally, the polypyrrole was observed growing on the carbon nanotubes, forming fiber-like structures. The FTIR spectra confirmed the presence of characteristic bonds such as carbon-carbon, single and double, nitrogen-oxygen, carbon-nitrogen, and sulfur-oxygen double bonds. The thermogravimetric analysis indicate weight loads into phases. The first between 30 and 100 degrees Celsius attribute to the water evaporation, and the second between 200 and 600 degrees Celsius due to the thermal decomposition of the polypyrrole chain. Regarding electrical conductivity, the results indicate a semiconductor behavior with conductivity increasing as temperature rises. The addition of sodium dodecyl sulfate and carbon nanotubes significantly improve conductivity. And finally, the open circuit potential analysis demonstrated the coating's effectiveness against corrosion with the polypyrrole sodium dodecyl sulfate carbon nanotubes coating exhibiting a near linear behavior indicating high stability and anticorrosive effectiveness. In conclusion, FTIR analysis confirmed the presence of characteristic bands of each compound. Send micrographs revealed a typical cauliflower morphology of polypyrrole. All coatings show semiconductor behavior with electrical conductivity increasing proportionally with temperature. Among the coatings studied, the polypyrrole sodium dodecyl sulfate carbon nanotube system stood out by offering the best performance in the TGA and OCP test, as well as exhibiting the highest electrical conductivity. This result highlight the potential of these coatings for anti-corrosive application in demanding environments. Well, that's all, and thank you so much.